We write down a question. Determine the complex exponential Fourier series representation for each of following signals. A. Xt equals to cos omega naught t. We want to calculate exponential Fourier series, complex exponential Fourier series coefficient of these. Cos omega naught t. We can expand this cos omega naught t with this formula, plus e power minus j omega naught t, bracket close. Here xt is summation n equals to minus infinite to infinite cn e power j omega naught t dot n. We can compare these two terms. For comparing, this term is denoted by this. By putting n equals to 0, c0 equals to 0. By putting n equals to 1, c1 equals to half. c1 equals to half because e power j omega naught t dot 1 into half. N equals to minus 1. C of minus 1 equals to half. Again, half e power j omega naught t minus 1 into minus 1. It is compared with these two terms. We got the exponential Fourier series coefficient in this case. Question B. Xt is sine omega naught t. Again, we want to find out the exponential Fourier series coefficient. Expansion of this term is omega naught t minus e power j omega naught t. With the expansion, we find out the coefficient of Fourier series by putting the value. First we find c1 equals to 1 upon 2j, c of minus 1 equals to minus 1 upon 2j, c0 equals to 0, means c of n equals to 0 for n equals to mod n equals to not equals to 1. By comparing with original expression, we find the result. Expression of Fourier series expansion minus infinite to infinite cn e power j n omega naught t. Omega naught t, again omega naught t. Value of n is vary between minus infinite to infinite, all integer value. Now take third example. third example. Third example is xt cos 2t plus pi by 4. Here value of omega naught is equals to 2. We compare with original equation, we find different result. First I have to write down expression n equals to minus infinite से infinite e power j n omega naught t. N equals to minus infinite से infinite e power j n omega naught equals to 2t. Expansion of xt half e power j 2t plus pi by 4 plus e power minus j 2t plus pi by 4. Expansion through Euler formula. E power j theta equals to cos theta plus j sin theta. Expansion through this formula. Compared to result, we got different value of Fourier series coefficient. Further solve, little bit solve it. Is pi by 4 e power minus 2t plus 1 by 2 e power j pi by 4 e power j 2t. Complete expansion of Cn. C1 equals to half e power j pi by 4 half with the Euler formula. Again with this formula, e power j pi by 4 is j pi by 4 is cos pi by 4 plus j sin pi by 4. 1 by 2 cos pi by 4 1 upon root 2 plus j 1 upon root 2. C1 equals to 1 plus j 2 root 2. Now second term, c of minus 1 half e power minus j pi by 4 half 1 minus j upon root 2 is our answer. We conclude as Cn equals to 0, k is not equals to 1. We got only two coefficients C1 which is upon 2 root 2, C of minus 1 1 minus 2 root 2. Question number fourth portion of the question, cos 40 plus cos sin 60. Period of this is 6, period of this pattern is 4 and this pattern is 6. Omega equals to fundamental frequency of these two terms is greatest common divisor between 4 and 6 equals to 2. Fundamental frequency is 2 now. Basic formula, summation n equals to minus infinite से infinite Cn e power j n omega naught t. By putting omega naught, value of omega naught, we got j n 2t. By Euler's formula, expansion of these two terms, half e power j 4jt plus e power minus 4jt bracket close plus half j e power plus j 60 minus e power minus j 60 bracket close. Now we compare these two terms by solving. Minus 2j e power minus j 60 plus half e power minus j 40 plus half e power plus j 40 plus 1 upon 2j e power plus 6j. We got different coefficient. C minus 3 equals to 1 upon 2j minus 2 equals to half, 2 equals to half, and C of 1 upon 2j, and all others are Cn equals to 0. In this way we can find out the different coefficient of Fourier series. Now we move further with last question E. Xt sine square t. Further solve as 1 minus cos 2t upon 2. 1 by 2 minus 1 by 4 e power plus 2 jt minus plus minus 2 jt. By comparing the coefficient term, we find C0 equals to half, C1 equals to minus 4, and C minus 1 equals to minus 4. By comparing the standard equation, we got the result half minus 1 by 4 minus 1 by 4. We can find out the different coefficient for Fourier series expansion. Next, we discuss Parcel relation for Fourier series expansion. Parcel relation for Fourier series expansion. As per Parcel relation, the total average power in a periodic signal equals the sum of the average power in all of its harmonic components. Mathematically we can represent in this way: power in time domain of a periodic signal is also given by Fourier series expansion, where limit is from minus infinite to infinite. This term denote power of the periodic signal can be calculated can be calculated. Power of periodic signal can be calculated with partial relation with Fourier series expansion. We have to add square addition of all the Fourier series coefficient. We can get total power, average power per unit time. Next we consider a periodic impulse train. Next we consider periodic impulse train. Periodic impulse train, which is represented by del t. T is denote fundamental period, function of t, summation n equals to minus infinite to infinite del t minus nt. It is mathematical expression of periodic impulse train. Ideal impulse train is periodic impulse train shown mathematically. Now we draw a diagram for periodic impulse train. By putting different value, we can get impulse train at 0 location, t location, 2t location, 3t location, 4t location, and 5t, and so on. Negative also we get same type of pattern. We want to calculate Fourier series expansion for this periodic train. For Fourier series expansion, we have to put this impulse train on formula. Our formula for Fourier series expansion is Cn e power j n omega naught t, where omega naught equals to 2 pi upon capital T, and Cn comes from this formula 1 upon t, limit for t xt e power minus j n omega naught t. Here xt is replaced with one periodic pattern. Xt is replaced with one periodic pattern. This pattern is repeat after capital T time del t e power j n omega naught t dt. This impulse is located at 0 location, so we have to put 0 in this, and value of integration is reduced to 1 upon t. The coefficient of Fourier series coefficient of impulse train is 1 upon t. This coefficient we use in sampling theorem and communication also. So we derive Fourier series coefficient term. After deriving Fourier series coefficient term, now we represent Fourier series expansion. Exponential Fourier series expansion for impulse train is 1 upon t summation n minus infinite से infinite e power j n omega naught t. We can expand with this formula, where Fourier series coefficient is 1 upon t. Now this Fourier series coefficient can be represent in terms of trigonometric Fourier series. Fourier series, trigonometric Fourier series. How it is possible? Putting the formula for trigonometric Fourier series, summation 1 to infinite an cos n omega t plus bn sin n omega t. Value of a naught, dc value of an and value of bn. Impulse is a even function for a period, so bn is not valid. We have to calculate only two terms now. It is a even function. We have to calculate only dc term and an term. For calculation of dc term, we use this formula 1 upon t from t del t dt. Value of this is 1 upon t. For an calculation, 2 upon t del t cos n omega naught t dt. By putting 0 in this expression, we got 2 upon t. The final result for Fourier series expansion 1 upon t plus 2 upon t summation n equals to 1 to infinite an cos n omega naught t. This is the Fourier series expansion in term of trigonometric Fourier series. Trigonometric Fourier series. Complete impulse train is represented by both the ideas trigonometric and exponential Fourier series. Exponential term we use in sampling theorem. With this, I end this topic.